All right, I'm Joshua Bakita, a PhD student at the University of North Carolina at Chapel Hill, advised by Dr. James H. Anderson. This project is trying to address a tension we see coming with future autonomous aircraft systems. Right now, certifying an entire system is correct all at once. We say, here it is, it's done, this is now going to run for 50 years. But that's not how software works these days. We've got continuous deployment. We've got constant improvement in algorithms. And so now what do you do when 2 years down the line from the completion of your new autonomous drone, there's a complete revolution in how we do planning? What do? We've already certified our system. We don't have any way to swap pieces in and out without breaking everything else. That's the tension we try and address in this work. We look at creating a sort of sense of composability in the system, where you can have individual components that can be swapped in and out, such as planning, mapping, localization, as separate tasks that can run independently and be swapped out. Whereas the system as a whole guarantees that no matter what is in each of those components, the others can still meet their emit temporal guarantees. So they can meet their deadlines, they can do their executions, and they will be completely unaffected if you swap out a different component. We particularly look at this from the angle of when you add in accelerators like GPUs, which are necessary for common computer vision tasks. Making sure that when you use them, it's not going to allow some type of, it's not going to bleed over between one component to another. Because right now, if you have something that's non-preemptive, meaning you can't stop it, if you start it right when you're about to run out of time, it's going to bleed over into the next component and cause that component to not be able to access a resource it needs. And so swapping out one of those components with one that's got this faulty late access is going to break a different component. And so we both build a framework to fix this and transform analysis to think about how can we actually make formal guarantees when you have this new type of componentized setting. And there's a few other additions we make from a systems level. For example, providing much faster memory over subscription. This is a way where you normally have a limited amount of memory, and you want to be able to use more than is actually available. And in this type of componentized system, it actually emits useful properties such that you can allow the system to use more memory than is available via some sort of very witty paging to and from a type of device called a solid-state drive. Yeah, so that's about what we've done here, and we're hoping to soon test this on an actual drone.